Repeat after me, or fill in my blank. Is it better? The sum of interior angles. Sides minus 2 times 180. The sum of exterior angles will always be 360. Now, these guys, I'll take one of two. Sum over sides and sum over sides. Or, technically, this is n minus 2 times 180 over n. This is 360 over n. That's a quarter point apiece. Quarter point apiece. Graphing a line. We want to get this into y equals mx plus b. So we're going to minus 4 both sides. And so I have y equals 3x minus 4. How do we graph? Graphing the intercept is at negative 4. My slope is 3 over run. There's our rise. There's the run. So I'm going to go up 3, 1, 2, 3, and over 1. Down 3, 1, 2, 3, and over 1. Either way, my line is like so. Now, points. They get the correct intercept is negative 4. That's plus 1. The correct slope, where it's down 3 and over 1, that's plus 1. So 2 points total. Guys, and if you're way off on this, please write in the note and say, see Miss Way in tutoring, because you have got to get graphing of lines down properly.
No, I just put it on. Then put negative 1.
Did I do this wrong? At the bottom. Guys, listen up. There's going to be several variations, so let me give you some basics, and then I'll open up for what do you have. Happily. There you go. You okay?
Yeah.
Okay, same. They have 4 sides. Same. The angles sum 360. How are they same? The most important one is that the diagonals make right angles. So the diagonals are perpendicular or right angles inside. All right. Anybody else have something there? How they are the same? Raise your hand if you want me to see. Okay, difference going to be a little bit harder. Difference. A rhombus has 2 pairs parallel sides, whereas a kite, no pair of parallel sides.
Oh, no.
In a rhombus, opposite angles are congruent and cut in half. In a kite, only 1 pair of angles are cut in half, not both. In a rhombus, all 4 sides are equal. In a kite, only the consecutive sides are equal. Any other variations down there? How are they different? Raise your hand. I'll be happy to address it. Anything else down there?
I don't have a 4.5.
Those are 1 point apiece at the bottom. Score it up out of 5 in return.
I know I got that 5. I know I got it. I know I got that 5.
All right. You now have 5 minutes to get this corrected. You now have 5 minutes to get this corrected.
Yeah. Guys, quiet.
Hi, Miss Lars.
Hi, Caitlin.
Did you know the Robinson was people who invented the art?
We're getting there today. Absolutely. You're feeding my lines here. Very good.
Guys, will you be quiet?
I'm experimenting. I'm trying to figure out who's going to be the last person talking. Close. Alrighty, guys. Now, I do realize it's Friday, so I'll give you but when I ask for your attention, guys, it shouldn't take 3 whole minutes, okay? So, and the only reason why is because I have an extra credit project that's kind of interesting, but we need to stay focused so that you can get to it. Let's recap where we've been. This will take us about 15 minutes. Look at the clock. I'm really going to shoot. I'm shooting to be done no later than the 40 by absolutely. Guys ready? Stay with me. Step number 1. We've been talking about quads. We did parallelograms by itself. Then we did the parallelogram children, if you will. That would be the rhombus, the rectangle, and the square. Today we're doing the non-parallelograms, which is a trap, an isosceles trap, and a kite. That's the non-parallelograms, and altogether, that's the quad family tree. So we're going to focus in mostly on quads today. Looking down here at the bottom, I'd like you to outline at least 3 not quads. I did say quads, didn't I? Trapezoids. Outline at least 3 trapezoids. Go. Outline at least 3 trapezoids. Go. Down there at the bottom. Anywhere. In either picture, outline at least 3 trapezoids.
I got one. It's a really good one. No one put it in.
I'm impressed. All right, how many of you did one of these guys here, like so? You did that, trapezoid. Okay, anybody do the capstone trapezoid? Yeah. Okay, who saw the trapezoid here? Good. Now here's a trivia question. Who knows which down? Wow, I'm impressed. Okay, you've been there. And where is it?
Colorado.
Nevada. It's Nevada. By Las Vegas. Very cool. Yes, ma'am. Another one?
On the other picture, yeah, all the way like towards the dam, but like the area that's not facing. No, it's not on the dam. I'll do it. I know I.
Oh, this one.
No.
You know what? Just come up here, dear, at this point. Be my guest.
Is this one right?
Yeah. Oh, okay, someone's an artist. Yes, someone can see that that's technically a trapezoid there. Very, very good. Alrighty, so, ready? Step number 1. This is called a standard trap. Standard means it's just a normal trapezoid. This is called an isosceles trap. First, we're going to talk about what makes them the same. The first thing that makes them the same is that they have what are called parallel bases. That's the definition of a trapezoid, is that you have 2 parallel sides. Or you could just write 1 set. Those are called the bases. Write that down, please. 2 parallel sides or 1 set. Richard, listen up. Guys, I don't want to talk over you. Really, I'm trying to make this as fast as I can. But if I talk over you, you're distracting somebody. Mr. Jolly, yes, sir. May you what? Of course, thank you for asking. 1, and next thing they have all together, all 4 angles. You guys just complete my sentence. In a quad, all 4 angles always add up to how much?
360.
No, all 4 angles.
540.
Wow. 4 minus 2 times 180. 2 times 180. Yes. All 4 angles. Sum 360. Sounds like you were guessing. That's why I didn't take it right away.
Yeah, I never guess. I know.
There you go. Now, the next one is consecutive angles. Angles that are next to each other. The squiggle angles here and squiggle angles here. Those are called consecutive. They add up to 180. Consecutive angles sum 180. That is true of all parallelograms. All parallelograms. No, I just said parallelograms, didn't I? Trapezoids. Trapezoids. That's true of parallelograms as well. Last one. I like you to eyeball the midpoint here. Eyeball it and draw a point. Eyeball it here, draw a point. Connect. That has a name. Raise your hand and tell me, what is that name of that pink line?
Median.
Does a bisect? It's a what, Luis? Median. Excellent. It is a median. I'd like you to write this equation of a median. Write median equals base plus base over 2. But guys, be really careful. Bases does not mean bottom. These guys here on the left-hand side, even though they're sideways, those are bases. You got that? Okay, now we're going to do different. What makes an isosceles trapezoid different? Look over here. Here's an isosceles trapezoid. There's actually 3 things I like you to write down here in the margin. Congruent, congruent, and congruent. There should be a 3rd bullet there. Ben, Mr. Courtney, can I have your attention, please?
Me?
Yes. Annalise, cell phone away.
Busted!
Dude, you got caught, Eddie.
You can't get away with it.
We're gonna get some noise.
You never know.
Okay,
Okay, you guys ready?
Oh, yeah.
Step number 1, what makes an isosceles trap different is that the legs, which are the non-parallel sides, you have congruent legs. You have congruent legs. If it's isosceles, you have congruent legs. Yes, sir. Yes, well, because you just now focused in. Okay, so the isosceles, if you have 2 equal legs, there's 2 other things that are equal. These angles connected to the bases, dark green and light green, they are congruent. So congruent base angles. This is what makes an isosceles unique. And then there's one more. Wait till you write that. See those red dots? Connect them, please. Hang on. Don't put it down. See the orange dots up here? Connect them, please. Okay.
No.
2 things. Those do not bisect each other, nor do they bisect the corners. But there is something unique about these. I'll let you figure it out.
In the middle.
Not exactly. Not exactly, but thank you for trying. They're the what? They are exact. If you finger bracket, guys, use your fingers. Bracket the red on your paper. Bracket the red. Now turn around and bracket the orange. You should feel that they are the same length. They do not cut each other in half, but they are congruent, diagonal. Write the word lengths. That makes an isosceles, right? Isos, really big.
Isos.
Okay, we're going to skip the kite because we're going to come back to it later.
We're gonna have anything that we do outside anymore for this year?
Not yet. No, we're not skipping the kite. Go to the kite. Ready? There's some vocabulary you need with the kite. I'm going to mark everything that you know. If I say the word kite, you should start marking this. Most importantly, what kind of angle's on the middle?
Right.
Right angle. So put your right angles in there.
Oh my gosh.
Yeah. Not a field trip. I mean, we do outdoors activities. There'll be 3 more outdoor activities, but not field trips. Okay, next, hatch marks. Those are equal going that way. Warning, the tall one is not equal. Mr. Courtney, how you doing? These guys, those are called vertex angles. Vertex. Well, if we were focusing on geometry, we wouldn't be offended because there's nothing I said that's offensive right now. Hatch marks. Hatch marks. Those are cut in half. What else is true? These are congruent, and then these are congruent. The consecutive angles. And there's one more. These yellow angles, they are congruent, but warning, they're not cut in half. Those yellow angles, they are congruent, but not cut in half. When you're done getting all that down, turn the page.
Why are they not going to do?
You know what? That's a very good question. How about, let me draw this. I was waiting for someone to ask. Thank you for asking. Kyle, look here. I'm going to draw a really, really skinny kite. Okay, ready? Okay, well, now watch. If I go like this, if I sweep those yellow angles, do you see that the yellow's equal? Do you at least see that, Kyle? But if I draw in that, I have a shorter and a longer. Okay, it looks like it's bisected here because it's kind of a squashy kite. Okay, so the yellow's equal, but it's not cut in half. That's a good question. Good. We're almost done here. Go to this page right here. I told you 40. We're actually going to be about 3 minutes ahead of the game.
Oh, the way my breast was really good.
I did too.
Okay, first, before I give this example, let me talk about extra credit. Come here, guys. Looking, see these tiles? Okay. Today, once we finish these two problems, then you guys, your sign off, which means required to be done before you leave, is pages 4, 5, 6, and when you get to 7, you need to get a little cup of tiles. 7's required. Now, when you finish 7, you can come get a sign-off for being done. Here's your extra credit. The extra credit, timing-wise, you need about 10 minutes to clear. So if you want to actually have a reasonable possibility of getting the extra credit, you need to be working on this no later than 2:15, just to give you a heads up. After you do the tiles for page 7, 8, if you're able to finish 8 and get the right answer, and it has to be accurate, and you come to me before you look at my black answers, and you're accurate with all the work, that's going to be 5 points extra credit. Okay, let's talk here about the significance of a trapezoid. Let's go back here. Trapezoids. Why are trapezoids important? Caitlin, can you share with me the piece of trivia that you shared with me about 5 minutes ago?
Oh, the Romans invented the art.
Yes. Now, guys, I want you to think about this. This is a Roman arch. If you go to Egypt, although they had amazing architecture, they do not have arches. Greece, when you go to Greece, you look at Greek architecture, they do not have arches. It was the Romans who invented this arch. Now, I need you to have appreciation for this. What are the shape of the blocks in that arch?
Trapezoid.
You see it's trapezoid?
Squares.
Squares on the outside, trapezoids on the inside there. Now listen, those have been standing for almost 1,000, probably close to 1,800 years. There's no cement, and there's no mortar. There is nothing holding those blocks together except gravity and the accuracy of the angles.
They put the top in.
And that's the capstone once they put it in.
Wait, is that seriously true? Still to this day?
Yeah, that's a current picture.
Yeah.
Knock it down.
You see the kid with the motorbike?
Yeah.
Yeah, that's current. So these arches have stood the test of time nearly 2,000 years just by the accuracy of how they were cut. So you guys, let's talk a little bit more about trapezoids. Ready? Go to this page. Step 1. We're going to solve for x. I'd like you to sweep these two angles, please. Sweep. Ready? Go. Sweep and sweep. Sweep and sweep. Mr. Fields, what do we know about those consecutive angles? Tell us a tidbit. What do we know?
About the consecutive angles?
Yes, sir.
Equal.
They're not equal.
180.
They add up to 180. Great. Let's solve for x. So we're going to go 100 plus, guys, this back team, we're having a running conversation on the geometry. If you can talk and work at the same time, it's fine, but I've had to redirect you guys 3 times.
We're sorry.
So, all right.
I'll take
I understand, Kyle. Focus, buddy, and then you guys can chat and work all at the same time. Ready? Solve for x and check your work. Go. Should only take you about a minute. Do not say your answer out loud, please. Do not say your answer out loud. Fabulous.
Oh my God.
Wait. I like these.
Self-correct. Self-correct. Did you plug it in? Check. Did you self-correct?
Right?
You gonna self-correct? Okay, look up here, guys. Yes, but guys, don't get all happy when you solve for x. Learn to plug stuff in and check it, because if you put x is 10 there, you get 80 and 100, it's 180. Okay, now I'm going to do one more thing. I told you 40, so we're right on target. We have 2 minutes left. This, it says GH is a median. I'd like you to write the word median. All right. Sounds like it, yes. Now, write the word median here. Now we're going to write the equation for median, which is just the average of the bases. The bases are the parallel sides. So we have base, yes, plus base over 2. Now I'm going to ask you to do something, and you need to, I'm going to tell you, I had at least 6 students in the past 3 periods make mistakes on this because they failed to do one of 2 things. One, they did not write down the equation. You will write down the equation every single time. 2, not only will you write the equation down, but you will do physical pickup. Let me show you what I mean. This is what I mean by that. Circle the word median. Now come up here and circle the value of the median. That's what I mean by physical pickup. You physically circle the numbers and plunk them in. And then base, circle base, plunk it in. Base, base. And then look here, there's a 2 there, so this whole thing's over 2. Richard, you guys can stop your staring contest now.
What's UX?
Okay?
You get the exam staring contest? That's cute.
All right, and now, physically cross multiply, solve for x, go. Solve for x, go. This is your last problem, solve for x.
I haven't won yet. There's not enough room to do it.
And then bleed over into the other side.
I haven't blanked yet. No. I'm really that time. Can't tell. There is no white in my eyes. He was trying to get small. I'm not sure. Oh, I'm not trying to get small.
Should I solve for x? What'd you get for x?
Yeah.
Because it's an average, buddy. Average. And add divided by 2. Right, take a look up here, guys. X equals 7. But what's nice is you can check it. You get 12 and 20 for the basis. You add them up. You get 32. You divide by 2. 16. 16. All right, go on to page 4. Get started on page 4. Do and check. Oh, no. Yes, your goal is to finish pages 4, 5, 6, and 7 in class. No, go straight to page 4, guys. Go straight to page 4, please. Straight to page 4. No, skip the kite. You're going to do it later.